Okay, hey, I wanted to post a video that kind of went through what the answers were for these free response questions for the FRAPPs, or the free response questions that came from chapters 1 and 2 for the nuts and bolts here. So we're going to take a quick look at each of these. I'm going to post the rubrics for you so that you can kind of look at those if what I'm talking about here doesn't answer your question. But on this first one, this was talking about the United States Department of Agriculture's super dump cleanup efforts in the early 1990s. There were various sites in the country that were targeted for cleanup. 3 of these targeted sites, River X, Y, and Z, had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below display the 5 number summaries for the concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers. Okay, now here's the question. Okay, the question says compare the distributions of the concentration of aldrin among the 3 rivers. Now, when you hear the phrase comparing distributions, it's going to want you to compare these 3 things: the center and the shape and the spread for the 3 distributions. And what you would not want to do is just list the center, spread, and shape for River X, and then separately list it for River Z and then River Y. They want you to use comparisons. So you can see how I kind of have this organized here. For the center, I found up here in the box plot where each of the medians were. Okay, that's the middle of each of those boxes. And then I'm using comparative language by saying, okay, River X, it had the highest, and then here's my context, typical concentration level, and I went ahead and just gave an estimate of what that looked like, and you can see I wrote it right up here on the graph. And then I kind of listed them in order, then River Y, and then it was followed by River Z. Okay, kind of listing them in order. And then I went through, did that same thing with each of the other kind of parts of comparing the distribution, talking about spread. We can see that River Z had the least amount of spread, or the least amount of variability, and then the next was River Y, and then River X. And in parentheses here, I'm putting, kind of some context here. So these are what the ranges are of those concentration levels of aldrin. Okay, and you can see for shape, I'm just kind of comparing what each of the shapes are. Okay, now I'm just going to scroll real quick down to the rubric because I want you to just look at the rubric for this part here. You'll notice that it mentions on the rubric that it's you only get essentially correct if the response correctly describes in context, okay, the center and the spread and the shape of all 3 distributions, and you have to use a comparative statement. It says involving all 3 distributions in at least one characteristic. So I tried to do that as much as I could on all of these, but it would at least, like with the shape, want you to, kind of compare. This was the highest, then this, then this. Okay, so keep in mind when it asks you to compare, that's what it's looking for. Okay, let's move down here to Part B. Part B is wanting you to take these 20 concentration levels and basically construct a stem plot. Okay, the important part is remember we've got this vertical bar here that kind of separates different parts of your number. Everything on this left side is the ones place, and everything over here on the right side is the tenths place. I think the crucial thing is you have to provide some type of a key. Okay, where you are listing over here an example, and then you're also listing, what that 7 with a line 3 translates into, and that would be 7.3 parts per million. Okay, and these just get organized from, least to greatest here. Okay, and then in Part C, it says describe the characteristic of the distribution of aldrin concentration in River X that can be seen in the stem plot, but it cannot be seen in the box plot. Okay, so I'm just going to scroll back. Let's look at the box plot for River X. Okay, that's this one right here at the top. Okay, and then I'm going to scroll down and we're going to take a look. This is River X as a stem plot, and it should be relatively noticeable here that there is this distinct gap right here in the middle. And on the rubric, it says if you just say there's a gap, you're only going to get P for partial credit. You have to identify that there is a gap, and you have to state where it's at, okay? So we would want to say there's a gap between those two values. I probably should have said in the stem plot that is not evident, and this is not evident in the box plot. Oops, sorry. Okay. Okay, so let's move on to the next one here. On this next one, they're giving you all these different shirt sizes from small to extra large for men's shirt sizes here. It mentions that it's approximately normal. The average men's shirt size is 15.7 inches. Oh, I'm sorry, these are the neck sizes over here. Okay, we're talking about the neck sizes are normally distributed. The average men's neck size is 15.7 inches, standard deviation 0.7 inches. That allowed me to kind of summarize everything using this format right here. Okay, now you can see on the left column, then there are these shirt sizes that are affiliated with that. Okay, hopefully you guys found this one relatively easy. It says because the retailer only stocks the sizes listed above, what proportion, I want to ask you for proportion, that's really just talking about the area under the curve. What proportion of customers will find that the retailer does not carry any shirts in their sizes? Okay, on the rubric, what you had to do is you had to acknowledge that we would be talking about, okay, neck sizes that are going to be smaller than 14 and neck sizes that would be greater than 18, and you would just do normal CDF, as you see what I have here, everything to the left of 14, and then another normal CDF for everything to the right of 18. Those two get added together. This would be the proportion of people who unfortunately would not have a shirt in their size. Okay, looking down at part B, it says using a sketch of a normal curve, illustrate the proportion of men whose shirt size is a medium. Okay, I encourage you guys strongly when you're doing these problems, read very carefully what the problem's asking you to do. They are demanding on this problem that you are drawing a sketch, okay? And so you can see how I went ahead and labeled the mean right down the middle here and kind of gave some estimates here as to here's where the medium would kind of fall. But we're just talking about the area in between those two values, and you can see I just did normal CDF to get that. Okay, now when you get to part C, though, this is really a little snippet from chapter 6, honestly. It says, of the 12 randomly selected customers, what is the probability that exactly 4 would request a size medium? So the key here is we're talking about exactly 4, not more than 4, not less than 4. This is an equal to problem. When it says there are exactly 12 customers, the reason that this is a binomial distribution is because the n is a fixed number of trials. In this case, there's a fixed number of customers. The p is the probability of a success. In this case, the probability of your shirt size being a medium. And you see this a lot in free response questions. See how our answer in part B, where we calculated this is the probability of someone needing a size medium shirt, and then we find ourselves needing to use that answer down here in part C. That would be this probability of a success, or our P. Okay. Now there's 2 ways that you can do this. Option 1, you can use the formula on the formula sheet for calculating a binomial probability. That is exclusively for an equal to problem, which is what this is. Okay, now notice that you have this formula here, but it really requires you to do this calculation on your calculator, which is under the math probability menu. Okay. This is the probability of a success, that's size medium shirt. This is the probability of a failure. We want 4 of the 12 to be size medium shirts. That means the other 8 of the 12 would not be a medium. Okay. The other option, the other way of doing this problem is to use your calculator, but instead of binomial CDF, you would be using binomial PDF. PDF means it's an equal to. Okay. It's going to ask for 3 inputs: the number of trials, probability of a success, and then in the end, X, which is how many successes are you wanting to calculate. Get the exact same answer either way. Okay. All right, and then our last one here. This is an old one from 2001. Excuse me. They give you some summary statistics for the number of inches of rainfall in Los Angeles for 117 years beginning in the year 1877. We won't use all of these numbers here, but it does ask you to describe a procedure that uses these summary statistics to determine whether there are outliers. And I probably should have elaborated a tad more. I put the formula for the lower fence. I probably should say something like any values below the lower fence and any values above the upper fence are outliers. That's what I should have written there, okay? And you'll notice when I wrote the formula, I've got the interquartile range, and just to be very clear on my communication, I listed how you would get the interquartile range, okay? Now, the question is, are there any outliers? Which I really cannot answer this until I actually make that calculation. And so down here in part B, it says, well, justify your answer by actually using the procedure that you described in part A. Okay, and so you can see I just kind of walked through that here. Up above, I started with the interquartile range, and I grabbed Q3 and Q1, subtracted those to get the interquartile range. Okay, and then just using the formula, I got my lower fence, I've got the upper fence, and here's what I would want to look at then. What you really want to look at is you want to look at what's the maximum value and what's the minimum value, and do either of those two values fall below the lower fence or above the upper fence, okay? And you can see the min, that's not smaller than negative 4.675, so it doesn't look like I have any low outliers, but look at the max. The max is above that upper fence. Now, I shouldn't just say there is one outlier, because just because 38.180 is definitely an outlier, who's to say that there isn't another number that's maybe 37? Okay, all I know is this max number. So that's why I said there is at least one outlier, since the max of 38.180 lies above the upper fence of 33.65. Okay, see how I'm clearly communicating what my thought process is there for the grader? Okay, and finally, it says the news media reported that in a particular year, there were only 10 inches of rainfall. And so they're kind of alluding to the fact that this was like a real rare occurrence, that there would have only been 10 inches of rainfall in a given year. It says, use the information provided to comment on this reported statement. Okay, so here's the idea. If you look back at the 5-number summary and just kind of think box plot wise, okay, look at where our min is. It looks like our min value, if I were just think of a box plot, is 4.850. My Q1 value, that would be the left side of the box here, okay, that would be that. Okay, I'm not even going to draw the rest of the box here, but what I want you to look at is right here, the Q3 value is not even 10 inches of rainfall, okay? And so when we do box plots, we know that, each section of the whisker holds 25% of the data, and then like each side of the box is 25%. And so what we're saying here is that 25% of the rainfall that happened was between 4.850 inches and 9.680 inches. And so that's kind of indicating that 10 inches really isn't that rare of an occurrence if 25% of the readings fell between 4.85 and 9.68. Okay, so that's kind of the idea there. Okay, I hope that this helped for you to just kind of check through and see, like, maybe you lacked some context in places. But I get on the rubric if that would help, or rewatch any part of this if that helps as well. And I will be in touch with you guys.